Hello, and welcome to the WebbVR session at Communicating Astronomy with the Public. My name is Tim Rue. I'm an informal educator here at the Space Telescope Science Institute. I focus on outreach, communication, and education in an out-of-classroom experience. I'm part of the team that helps make WebbVR, including Doctors Alex Lockwood and Quinn Hart, our astronomers, and our VR developers, Chad Smith and Sam Silverman. For those of you who don't know, WebbVR is a virtual reality experience that allows for exploration of the universe and the science that the Webb telescope will be exploring after launch. It's available for personal or public use by anybody who would like in your home at an event. It's completely free to use, and we'll encourage you to check it out yourself. We'll show you a few videos and some other things as we're going along here today. With WebbVR, it's possible to fly around in a three-dimensional universe, including our solar system, protoplanetary disk, a distant galaxy, and an exoplanet system. There are sights to see and experiences to be had. You can take a swing around the moons of Jupiter. You can fire stars into a black hole, make your own planet, discover the effects of the snow line, search for distant planets using a variety of methods, and so much more. Today I'm going to take you through what makes VR a good tool for astronomy communication, why we decided to do all of this, how we actually tackled astronomy using VR, and let you know how you can find WebbVR yourself and give you some good ideas for using it on your own. So virtual reality is an amazing tool for astronomy communication. It helps us overcome a lot of the challenges that we face. So to be a little more specific, scale. The universe is a vast place. Even the distance between planets doesn't fit into human comprehension very well. And we also need to deal with the very small molecular atomic level to communicate certain ideas. VR helps people kind of experience some of these things. They can take a trip between planets and see what that feels like. And then when they start getting bored, we can just jump to the next place and we can start getting into some other concept that we'd like them to hear about. We can also go to a very big scale and let them see galaxies and move around between them. And we can go to the very small and look at individual atoms. It's very fluid. Also, VR is helping us deal with complex ideas that no one has seen in real life. We're here on Earth. We're working through data from telescopes on the ground, from telescopes in space. And nobody's actually seen these in real life. Nobody's experienced those. It requires a lot of imagination. And we who work in astronomy are thinking about this all the time, but someone who's not there every day, well, VR provides a physical thing that they can see, that they can move around, and it really helps them grasp onto that and have a place to move on and move further into the experience. Another way, one of our big tools that we normally use in astronomy communication are two-dimensional images. And we are able to give three-dimensional objects here in VR. In 2 dimensions, your image of a planetary nebula or a galaxy may be very misleading. It's this streak. Well, what does that actually mean? In VR, you're able to move around that in 3D space. You can do that in direction and in your own choice. We've got visualizations, but it's not quite the same when you have that set out experience for you as being able to freely explore this. And that visual hook really grabs people and gives them something to build on. People also have the opportunity for in-depth, unfacilitated time when they're working in VR, this responsive environment. Communication with astronomy is great when you've got someone there in person, but we can only do that for a small fraction of the public. By having VR, people can go and explore these really complex things. We can put in tooltips, and we can put in other things that pop up that provide guidance along the way, depending on the choices that they make. And it allows so many different directions of exploration, which is really a more effective way of learning different ideas. Lastly, VR is incredibly immersive. People learn better in a more immersive place, and VR takes advantage of sight and sound to bring you to a place that gives you that really lasting impression and more effectively reaches our communication goals, our education goals, and everything else that we're trying to do. So how did we tackle astronomy using WebbVR? Well, the first thing we did is, since it's WebbVR, we focused on the James Webb Space Telescope science themes. When you enter the program, the first thing you're going to see is the telescope right there, big and giant right in front of you, and you're able to move around it and see it from all sorts of different angles. And you're also able to check out different information hubs. You can press them or move up and touch them, and all sorts of information will pop up in different spots. You can learn about the Sunshield, you can learn about the spacecraft bus, you can learn about each of the different mirrors. And it's a great way to get a lot of the information in there. But then you can go in and explore more and have some experiences. For example, you can learn how the Sunshield actually keeps the telescopes cool. You can see when you enter this heat coming up from the sun, and you can see how it gradually decreases through the different layers of the Sunshield, but it still goes up around the size of the telescope itself. So that's a wonderful experience to get more of a visceral sense of what's going on in this a little more abstract idea. So beyond the telescope itself, all of the different explorable scenes within WebbVR are based on what Webb is going to be examining. We look at exoplanets, we look at young stars and planet formation, we look at what a galaxy is, how it develops, how the different pieces of it develop. And those are all really important things that Webb is going to explore, some of its major science goals. Beyond the science themes, another thing that was important for our approach is making sure we considered accessibility right from the start of our development. We've made sure that every piece of information in there are multiple ways to access that information. Everything that you want to do, there are multiple ways to get to that, to explore the environment around it. And this not only increases the number of people who can use the application, but it increases the ability of everyone to be able to use it effectively, which is really important to us. We want to get this out to as many people as effectively as possible. We also tried to balance the guided exploration and the self-guided exploration as you move through the application. People learn really well when they're able to direct their own way through an experience and when they're able to go at their own pace. But they also need a little bit of help along the way, particularly in a new environment. So there are pop-up hints and tips. If you go into a new scene and there's something there that you haven't done yet for a little while, a little thing will pop up and say, hey, have you tried this out? And that is not all that intrusive, but it's a good little way to help out. Like I mentioned, there's the ability to choose where you want to go, whether it be through the travel menu or through other ways, but that really lets people direct their own learning. And beyond that, there is a major piece that we're trying to get across, an objective that we have for the viewer in each different area. But then there's all sorts of pieces of science infused in the background. If you look carefully at all those details, if you know what's going on, you can see that. So it's a really great way to explore deep. There are some challenges to putting all of this together as well, of course. VR is it requires a computer to work. And computers only have so much that they can do. So we have to balance that computational power with realism. So our current limitations, for example, prevent us rendering volumetric effects in there that you might have with gas or dust. But we've got ways to work around that. If we render a smaller number of particle effects with texture maps, we can create that appearance there, and that's a really great way to do it. So that's one of the challenges we'll work through. We also have to deal with scales. I mentioned scales are a great thing that you can do in VR, but you have to give them some sort of reference. So if you're in the solar system, you might need to reference how big the place is. Or if you're looking at stellar evolution, you might need to reference how long these time periods are that we're doing so that people have a way to compare with each other. So the last thing I want to leave you with is how you can find WebbVR, how you can use it yourself. It works in multiple platforms, both the Vive and the Oculus. We used to develop it. You can download and use it with either of those systems. And you can use it in a whole bunch of different ways. Potentially, you could bring it out to a festival. You could set it up as a standalone exhibit or a guided exhibit with someone there helping guide people along. You can also bring it to a different communications event. For example, say you're setting up something where you want to talk about black holes. You could bring WebbVR in and settle in just to the black hole section within there and have people shoot stars at black holes and see what sorts of things happen. And it can be a nice add-on to everything else you have going on. We know that we're in a kind of different circumstance right now between last year and this. So there are some, and people might not be comfortable putting a headset on their face, so there are some other ways to go about it as well. You could do a pre-recorded tour where you fly through different areas, or perhaps you put on a headset yourself and project what's going on onto a big projector screen for a live audience and walk people through different things. If you'd like to access WebbVR, stick WebbVR in Google, you'll get a link. You can see over here on the side, we've got links to both Steam and HTC Viveport stores so that you can pull it down again for free. And I'm just going to leave you with one final quote from an anonymous child user. I will never experience anything this cool in my life again, ever. I hope that that little girl does experience something as cool again, but I hope you all have a chance to have that same sort of experience that she does. So thank you very much.